All right, students. So 5.2 note sets operations with radicals. Okay, again, we are still not allowed to use a calculator. So make sure we can do all of these questions without one. So on your notes, students, you guys have these two blank lines. Okay, so make sure we copy this down. Addition or subtraction. First, we are going to combine like terms. The two rules are we must have the same index, okay, and the same radicand. Then some of the problems will require you to simplify your radicals before we can combine like terms, okay? So here are the examples. Add or subtract. 4 plus 3 times square root of 5 plus 9 plus 2 times square root of 5. So we are going to combine the 4 and the 9 together, put all similar square root terms together. 4 plus 9, that's going to give us 13. This right here, guys, is a square root of 5, and this is a square root of 5. They both are square roots, and they both have a radicand of 5. So this will allow you to combine like term because the radicands and the indexes are exactly the same. So pretend you're adding, okay? So this is kind of like adding 3x plus 2x. Well, that's going to give you 5x. In this case, it's going to give us 5, but not x. It would be 5. Oops, my 5's not coming out. Let's try that one more time. It would be 5 square root of 5. No, we don't do 5 and then square root of 25. We do not add the radicands, okay? So that's how we combine like terms. Now, sometimes we have to simplify before we can combine like terms. So for example, 4 times square root of 27. Square root of 27 is going to be 9 times 3. Then 3 times square root of 3, that's going to be as simple as it's going to be. Then minus 48, students. 48, if we don't know a nice number that goes in it, we can always start with 2 because it's even. 48 divided by 2, students, is going to be 24. Okay. Factor that out some more. 2 times 12, or some of you are like, well, I know 4 goes in there. 4 times 6 is 24. Yes, that works too, because 4 is a nice square number. Then you have 2 and 3. Now we can rewrite this like this. 2 times 2 times 3 times 4. And then we are going to simplify a little bit more. So 4 times square root of 9, y'all, is going to be 3. And then square root of 3 cannot be simplified, so that will stay. Drop down 3 rad 3. We can simplify a 2 and another 2. So outside is going to say 2 times 2. Rad 3 cannot be simplified because it's not a square number. On the outside, 4 times 3, students, it's going to be 12. 12 rad 3. Drop down your 3 rad 3. Then on the outside, 2 times 2 is now 4 rad 3. Since this is all square root and they all have a radicand of 3, we can definitely combine like terms. So 12 and 3, that's going to be 15 rad 3 minus 4 rad 3. That will allow us to write 11 rad 3 and box that up. Example 3 says cube root, okay? So cube root of 32x plus cube root of 108x. So cube root, we have to break it down into 3's. I know 32, students, is going to be 8 times 4. So I'm going to write 8 times 4 because cube root of 8 will eventually be broken down to 2, simplified down to 2. Now cube root of 108, okay? Now similarly, 108. If we don't know a perfect cube, start with a 2 since 108 is even. That will give us 54. Break that down. 54 is even. Divide by 2 for sure because it's even. Well, 27 goes in there. 27, that's a nice cute number. So I'm going to write 27 because cube root of 27 is going to be 3 in a little bit. And then I got 2 times 2. Okay, here we go. Cube root of 8 is 2. That can be simplified outside. Cube root of 4, y'all, is not possible to simplify, so I will multiply 4 times x back. Then, oh, you know what I forgot? I forgot to put that x back in there. Put the x back. Then cube root of 27, that's going to be 3. Those cannot be simplified because they don't make a set of 3 since we have an index of 3 here. So 2 times 2 times x is 4x. Okay. Now, if you look at the index, they're both 3. Look at the radicands, they're both 4x's. That means we can definitely combine like terms. 2 plus 3 is going to say 5. 5 times cube root of 4x, and box that up. So here are the guidelines, students, for multiplication or division. First, we must have the same index, okay? Same index. 2, multiply or divide coefficients, that means the numbers on the outside, with the radicals, okay? Multiply the numbers outside of the radical with the number outside of the radical. So outside, multiply with the outside. Multiply or divide radicands, inside numbers, okay? With the inside numbers only. So again, inside numbers with inside numbers only. Simplify the radical if possible. So outside can only be multiplied or divided with outside. Inside numbers can only be multiplied with the inside number, assuming that your index are exactly the same. All right, let's do these 2 right here where it says multiplying. First, let's check the indexes. We got 4 here and 4 here. So they are definitely the same. We don't have any outside numbers. All of these are radicands. So when you see that they're all radicands, what we could do is multiply the number together. So 3 times 5, n times n to the 7th, just like that. So on the inside, we have 3 and 5. They're both prime numbers and an index of 4 that could not be simplified out. So on the inside, we will have 4th index here of 15. Now guys, n times n to the 7th, that's sort of saying like this, n and n to the 7th, that's 7 more n's, okay? So I'm gonna write 7 more n's. 1, 2, 3, 4, 5, oops, I already have a dot, 6 and 7, okay? 1, 2, 3, 4, 5, 6, 7. That's n to the 7th, and there's an extra one. Well, if you think of it, we got 1, 2, 3, 4. Okay, index of 4 allows us to simplify one out. 1, 2, 3, 4. There's another one, so we can simplify 2 n's out, 1 and 1. So on the inside of this 4th index, we just have 15. On the outside, we have an n square because n times n is n squared with index of 4. And then we are going to have a 4th index of 15. Now, since your index is even, so let's look at it again. Your index is even, we have to check to see if our power is going from even to odd. Our power is definitely going from even because this is the same thing as saying, hey, 4th index, 15n to the 8th, right? That's an even power. But when it comes out, this is also even. So we do not need a square, an absolute value symbol. So that's just going to get boxed up. Number 5 says 3 times square root of 2 times 4 times square root of 10. This is going to allow us to say, okay, outside number 3 times 4. Inside number 2 times 10. Well, on the outside, we definitely have 12. On the inside, we're going to break 10 down to 2 times 5. Square root, y'all, that can be simplified down. 2 2's with a square root, that's going to allow us to simplify out a 2. Index of 2, well, this is only 1 5, so that's going to stay inside. Final answer is 24 times square root of 5. No variable, so we don't need to worry about an absolute value. Okay. Dividing. We have 2 cube roots, okay? When you divide, you can definitely rewrite them under one big radicand. That will allow us to simplify. Cube root 40 divided by 5, it's 8. Well, cube root of 8 is 2. So that's going to allow us to box that up. Now, method number 2. Okay, 2 different color. Method number 2 will allow us to go cube root of 40 divided by cube root of 5. Okay. Now we want to rationalize, cube root of 5. We want to rationalize the denominator. We only have 1 5 right there. So what's going to allow us to do is multiply 2 more 5s. Okay, so 5 squared. What we going to do on the bottom, we going to do on the top. So on the bottom, students, we do have cube root, and then this is 1 5, this is 2 5. So that's going to allow us to say, okay, 5 to the third. On the numerator, we can put them together. It's 40 times 5 squared. Well, 40 can be broken up, right, guys? 40 can be broken up as 8 times 5. And I have a 5 squared. So 5 squared can be written as 5 times 5. On the bottom, we're going to simplify. Cube root of 5 to the third, it's just simply 5. On the numerator, we have 3 5s. So 3 5s can be simplified as an outside number now. And we have a cube root of 8. Well, this can be reduced. Well, cube root of 8 is going to be 2. So as you can see here, 2 different ways, and we are going to end up with the same exact answer. Okay. Example 7. Remember, outside number can be divided or multiplied with outside number, and inside number can do the same. So that will say 12 divided by 4 times big radical 18 over 6. Okay. Well, 12 divided by 4, students, that's 3. 18 divided by 6, we can reduce that really quickly. That will give us 3 on the inside. Now, because we have a square root and we have a radicand of 3, that cannot be simplified anymore. So this is going to be our final answer. Now, method number 2, we could go this route, okay? So let's copy the question back down. Method number 2. Well, yes, we are still going to reduce the outside with the outside. That's not going to change. So that's going to say 3 on the top times 18 here, and then over rad 6, okay? Now, students, rad 18 is 9 times 2, right? So let's simplify that. 18 is 9 times 2 over rad 6. Well, 9 is a perfect square number. So rad 9 is going to be 3, simplify out. Then we have a 2 left on the inside. Well, this is now going to be 9 on the outside times radical 2 divided by rad 6. We can't have radical on the bottom, students. So we need to rationalize this, okay, just like this. Well, on the bottom, we now have rad 6 times 6, which is going to allow us to simplify that out. On the top, we have 9 times 2 times rad 6. That will allow us to say 9 times 6, because 2 radicals on the bottom with a square root, right? Now, rad 2, guys, will stay. 6, break that down to 2 times 3. Then, as you can see here, 9 times 2, the radical 3 will stay, divided by 6, okay? Well, let's reduce this to, okay, that will give us 3 here and 1 here. Then we can reduce some more, 9 and 3, that would be 1 and 3. So final answer, as you can see here, is the bottom is 1, which we don't need to write if the denominator is 1. On the top is 3 times 1 times radical 3, so that's 3 rad 3. Either way, students, you will have the same exact solution.